Now let's look at a problem in the context of a real-world situation. When multiplying matrices that represent real-world situations, not only must the number of columns in the first matrix be the same as the number of rows in the second matrix, but they must also represent the same information. Let's take a look. Matrix B, right here, shows the number of different types of baskets made by a college basketball player during the first 4 games of the season. For example, during Game 3, the player made 9 2-pointers, 3 3-pointers, and 8 free throws. Anyway, matrix P represents the points scored for each type of basket. So notice that a row represents 2-pointers, 3-pointers, and free throws. And then in matrix P, the column again represents 2-pointers, 3-pointers, and free throws. The only difference is that in the first matrix, we're talking about how many, and in the second matrix, we're talking about how many points they're worth. So let's go ahead and find the product of BP and then think about what it means. So the first thing we need to do when we think about doing the product is we need to make sure that it is possible, make sure it's defined. So that's all about the dimensions. The dimensions of the first matrix are 4 by 3, all right, because there are 4 rows and 3 columns. The dimensions of the second matrix are 3 by 1, all right, 3 rows, 1 column. So this will only be possible if the inner dimensions are the same. And they are. The inner dimensions are the same, so this is possible. Now, the dimensions of the answer, okay, so I'm going to be finding BP in a moment, but I'm going to need to know the dimensions of that answer, and that will be determined by the outer dimensions, which are 4 and 1. So the product BP will be a 4 by 1 matrix. So the next thing I need to do is set up an empty matrix that has 4 rows and 1 column. It's similar to what we did in the last problem. So here I've set up my 4 by 1 empty matrix. It has 4 rows and 1 column. I had to make it nice and big because when I do my multiplication, these are going to be 4 high. So let's go ahead and set up to find the first element, which is in row 1 and of course column 1. So remember, when I do my product, the rows are going to come from the first matrix. So the rows will come from here, and the column or columns will come from the second matrix. All right? So if I want to find the element that's in the first row and the first column, I need to do row 1 times column 1. All right, row 1 times column 1. So row 1 is 10, 4, and 6. Okay? I said these need to be 4 high, but they're actually 3 high. So row 1 is 10, 4, and 6. So I'm going to have 10, 4, and 6. Okay? Column 1 is 2, 3, and 1. Okay, let's go ahead and set them all up. All right, so to find the next element, the next element is in row 2, column 1. So I need to multiply row 2 by column 1. So that's 8, 3, 10. So I'm going to have 8, 3, 10 times column 1, which is 2, 3, 1. Okay, now my next entry is row 3, column 1. So that's why I am going to multiply row 3 by column 1. 9, 3, 8. And of course, column 1, as ever, we only have one column, so 2, 3, 1 again. All right, now to find the last element, this is row 4, column 1. So I need to multiply row 4 times column 1. Okay, that's 12, 1, 2. Okay, let's do it. So if I multiply these, I'm going to get 20 and 12 and 6. If I add those all up, that's 38. Multiplying here, I get 16, 9, and 10. Add them all up, you get 35. Multiplying here, I get 18, 9, and 8. Add them all up, you get 35. One more time, multiplying straight across, I get 24, and 3, and 2. So that is going to be 29. Okay. So I will take these values, and that is going to be my final answer for the product of matrix B times matrix P. So it's 38, 35, 35, 29. Okay, so that's going to be 38, 35, 35, 29. So this is the product B times P. Wait, before I do anything else, every now and then I accidentally leave out the N. Please believe I know how to spell the word column. I just, when I get in the flow of things, I start to spell phonetically. But I know that there's an N in there, columns, there's a silent N. Now, look at number 2. What are the column and row labels of BP? In other words, they're asking us to think about what do each one of these numbers represent? What do these numbers mean? Well, let's look back and remember where they came from. Okay, remember this 38, we multiplied row 1 times column 1. Okay, now what were those things? So look back at it again. Let's go back to row 1 for a minute. In row 1, we were talking about game 1, and it was how many 2-pointers, 3-pointers, and free throws were made. And then we multiply by the column 1, which is how many points you got for each of those. So when you multiply those together, when you do 10 times 2, we're saying there were 10 2-pointers, and because they were 2-pointers, they were 2 points each. So 10 times 2, that's giving you the total number of points from your 2-pointers. So we got 20 points from the 2-pointers. And then we did 4 times 3 because we had 4 3-pointers for a total of 12 points. And then we had 6 free throws, which were 1-pointers, for a total of 6 points. So when we add these things up and got 38, 38 is the total number of points from game 1. Okay, all together, all right? 20 points from the 2-pointers, 12 points from the 3-pointers, and 6 points worth of 3 free throws. So game 1 had a total of 38 points. Okay, so when we label this, we should say that this is game 1. Okay, and of course, this represents the total points. All right, total points scored. And then the second row should be game 2 in a similar way. And this will be game 3. And this will be game 4. Okay, so 29 is the total points that the player scored in game 4. 35 and 35, that's the total points scored in game 3 and total points in game 2. So anyway, the answer for number 2, the column and row labels for BP, the column, like we said, is total points, and the rows are labeled game 1, game 2, game 3, game 4. So, what were the total points scored in all 4 games? So, the convenient way to find that would just be to add up all 4 of these numbers right here. That turns out to be 137 points. Let's look at one more real-world situation. Carla and Kayla are making 2 snack mixes by mixing dried fruit and nuts. The amounts of protein, carbohydrates, and fat in grams per serving for the dried fruit and nuts are given in Table 1. The number of servings of dried fruit and nuts in each mix is given in Table 2. Represent the information from Table 1 in a matrix called N. Well, look, really, it's kind of like this. It really already is a matrix. All right, I just need a little bracket around it, but I'll write it separately. So we have matrix N, okay, and without the labels, which I'll just leave up here, we've got, of course, 3, 61, 1, 20, 21, and 52. All right, so there's matrix N. Represent the information from Table 2 in a matrix called G. So again, really, this already is a matrix, but I could just put brackets around it, and I'll recopy it because it seems like that's what they want us to do. All right, and so this would be 4, 2, 3, and 3. Now, find the product NG and label the rows and columns. So once you label the rows and columns, it kind of gives you a table like this again. So, but let's do it. All right, let's figure out what the dimensions of the product will be. So understand that we are multiplying matrix N times matrix G in order to get the product matrix NG. So matrix N is a 3 by 2 matrix. All right, it has 3 rows and 2 columns, while matrix G is a 2 by 2 matrix with 2 rows and 2 columns. So it makes sense that this matrix will be defined because the inner dimensions are the same. That's important. Now the outer dimensions will tell us the dimensions of the final answer, the dimensions of the product. So since the outer dimensions are 3 and 2, the dimensions of matrix NG will be 3 by 2. That's important because we will now set up an empty 3 by 2 matrix. So for my empty 3 by 2 matrix, I need 3 rows and 2 columns. So I'm going to set it up like this. Okay, so can you see that I will have 3 rows and 2 columns in this empty matrix? All right, so let's go through one element at a time. So the first element, this is row 1 and column 1. So because it's row 1 and column 1, well, first of all, I'm going to get all my rows from the first matrix, and I'm going to get all of my columns from the second matrix. Okay, so when I talk about row 1, column 1, I'm talking about row 1 of the first matrix and column 1 of the second matrix. All right, row 1, column 1. Okay, so row 1, so that's 320. Okay, so row 1, so I've got 3 and 20. And you know, while I'm at it, I'm going to do all of the row 1s. So this is still row 1, so it'll also be 320 when I get to this element. Okay, and then I have column 1, which is 4, 2. Okay, so column 1 is 4, 2. So I might as well do all of the column 1s. So this will be 4, 2, and this will also be 4, 2. Okay, so let's go ahead and fill in the rest of the rows and columns. So for example, row 2. Okay, when I talk about row 2, I am talking about this, since all the rows come from the first matrix. So row 2 is 61, 21. So 61, 21. This is row 2. This is also row 2, 61, 21. Okay, let's just get all the rows out of the way. So what about row 3? Okay, here's row 3, 152. So I will have 152. This is row 3. This is also row 3, so 152. Okay, now let's do the other column. We already did column 1. Now what about column 2? All right, column 1 was 4, 2, but column 2 is this 3, 3. Okay, so 3, 3. All right, and this is also column 2. And this is also column 2. So if we multiply these numbers, we get 12. Multiply here, you get 40. Add them up, that's 32. Actually, that was a mistake. So I said 32. This is 52. So ignore the 32. That's a 52. Okay, similarly, multiply these numbers, you get 260 and 42. Add them up, you get 302. All right, multiply and add, you get 4 and 104, and then 108. Multiply these together, you get 9 and 60. Add them up, you get 69. Multiply these, you get 195 and 63, which adds up to 258. Let's multiply these. You get 3 and 156, which adds up to 159. So the product matrix NG is going to equal 32. Again, 32 was wrong. This number is a 52, not a 32. 302, 108, 69, 258, and 159. Now, in addition to finding the product, we need to label the rows and columns. Just remember that the rows came from the first matrix, and the columns came from the second matrix. So when we go to label these, the rows, the labels for the rows will come from the first matrix, and the labels for the columns will come from the second matrix. So let's do the rows from the first matrix. Okay, the rows from the first matrix were protein, carbohydrates, and fats, in that order. So this will be protein, and I'll just say carbs, and fat. The columns came from the second matrix. So to get the labels for the columns, let's look at the second matrix. All right, here's the second matrix, but we're looking at the columns. The columns are sports mix and camp mix. So those will be the columns here. Sports mix and camp mix. Okay, so one more time, when you label the product, get the labels of the rows from the first matrix and take the labels of the columns from the second matrix. So that puts us in a position to be able to answer questions like number 4. Determine which mix has more protein and which has more fat. Let's start with protein. Well, the sports mix has 32 grams of protein, while the camp mix has 69 grams of protein. So obviously the camp mix has more protein. Now, which has more fat? Let's see. The sports mix has 108 grams of fat, while the camp mix has 159 grams of fat. That means the camp mix has more fat as well. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.